Okay, good day everyone. So this week we'll talk about functions, then file input and output. So we'll start with functions. So a Python function is a set of statements that are grouped together and named so that they can be run more than once in a program. So the advantage of using a function is that you can reuse the function over and over again. Okay, I will show you some examples. For example, if you need to define, maybe you need to square numbers in many places in your code, so you can just create a function that will square any number that is input in the function. So you say, how do you create, let me use a spider, how do you create a function in Python? So to create a function in Python, what you need is def, def, the def command. Okay, the def command. So let's say we want to create a function that will square any number that is input in it. So we say def, then we can name our function. Let's name it square. Okay, then x, that is the input. Okay, so if the input is just one variable, then you put as 1. You can put anything, maybe a or b or anything. Then colon, this column must be there, is compulsory. Then you press enter. So when you press enter, if you are using Spider or Jupyter Notebook, so it will automatically indent it. So but make sure that after the def, okay, this is the def, that is, def means you want to define a function. Then this is the name of the function. Then these are the parameters of the function. Then you will use colon. So then you just say return x squared. Okay, so anytime you need to square a number, you do not need to use x *2 again. You just say square x. For example, you can say print square 5. So you say print square 5, it will print 25. Okay, it will print 25. If you can say print 50, it will print the square of 50, which is 2500. So anytime you need to square a function or a number, you just need to call the square function. Now what if you want to create a function that will find the sum of the squares of two numbers? Okay, so let's say def, what should we call the name of the function? Sum and square. Okay, two numbers, so we have x and y, or a and b. Enter again. So in this case we want to return the sum of the squares. Okay, that is, so x squared plus y squared. So this will return the sum of the squares of the two numbers that are input in it. Okay, so this is how you return. So this return means that this function should output x squared. This return here means that this function should output x squared plus y squared. So anytime you need to find the sum of the squares of two numbers, you just need to call the sum square function. So sum square x comma y. What is x? Let's say x is 5 and x is 3 and y is 4. Okay, and we run. So we're going to get 25 because 3 square is 9, 4 square is 16. So 9 plus 16, 25. So that's why we got 25 here. Okay, so functions can be more complex than this. Okay, functions can be more complex than this. For example, let's say we want to, in our previous class, I think maybe the first or second class, we wrote a code to calculate, to evaluate the chronicle delta. If you recall, the chronicle delta is defined, let me see if I can. All right, so this is the chronicle delta, the definition. So delta x y is 1 if x equals y, and delta x y equals 0 if x is not equal to y. So in our previous class we just wrote a code to do that, but we can as well write a function that will take care of the chronicle delta. So we can say def, okay, then we can call it chronicle, then we'll say x comma y, then we'll say if x equals y, then you should return you should return what? 1. Okay, because definition is that if x equals y, the value of the canonical delta is what? 1. Then if x is not equal to y, the value of the canonical delta is what? 0. So return 1. So else if x is not equal to y, okay, then return 0. Okay, so that is it. So we can now call we can say print our canonical delta, so let's say 4,4 we should get 1. Okay, and you see 1, but 4,3 should give us what? 0, because 4 and 3 are not the same. So anytime these two numbers are equal, okay, we're going to get 1. Anytime they are not equal, if you input 14 and 39, it will give us what? 0. Okay, we're going to get 0. But if you input 14 and 14, then we're going to get 1. Okay, so that is about our function in Python. So it's very simple. You need to do like 4 things. Start with the def, okay, then the name of the function that you want to create, the parameters that the function depends on, this colon, very very important. If this colon is not there, you get error. Then when you press enter, you must make sure that there is a tab between the first line of this def, so there should be 4 spaces. Okay, but if you are using Spider, you have no problem. All you need to do is what? Just press enter. If you press enter in Spider, it will automatically indent it. Okay, then this return must be given. If the return is not there, the function will be empty. Okay, what do I mean? If instead of let me mute this, control what? So if instead of saying def sum square xy return x square plus y square, we just say z equals maybe x squared plus y squared, and we forgot to return. Okay, we forgot to return. What will happen if we print the sum squared? We're going to get none. Okay, none. So you must make sure that after this return there will be a space, the return, then space, the function, that's all the output, what you want the function to output. So return z. So if you run it now, you're going to get what? An answer. Okay, so this is very very important. Then in this notebook I demonstrated how you can write the roots of a quadratic equation. A quadratic equation has 2 roots. Okay, so ax squared plus bx plus c, regular quadratic equation in secondary school. So the solution using the formula method is minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. So we can write a Python function that will return the roots of a quadratic equation. So what do we need? We need to output minus b plus square root of b squared minus 4ac over 2a. We also need to output minus b minus, so there will be 2 answers, because this is the power of this polynomial is 2. So when the power of the polynomial is 2, then there will be 2 results, 2 answers. If the power of the polynomial is 3, if this is x cubed, then we're going to get 3 results. So def, I want to create a function that will return these 2 roots. So I start with def, then the name of the function, I call it roots. Okay, then the parameters that the function depends on. So in a quadratic equation, we need a, we need b, and we need c. So I'm going to take this a, b, and c as the what? As the parameters. Then I said let this b squared minus 4ac, let it be denoted as d. So b squared minus 4ac. So d is b squared minus 4ac. That is b star star 2 minus 4 star a star c. Then the first root, root 1, will be minus b plus square root of d, which is b squared minus 4ac over 2a. Everything divided by 2a. You can see this 2a is in bracket. If you just write divided by 2a like this without the bracket, you are going to get the wrong answer, because it will first divide the result by 2 before multiplying it by a. But in this case, we want 2 to be multiplied by a first, then the result to be to divide minus b plus square root of d. Please make sure you use brackets. Okay, anytime there is a confusion, anytime you are not sure what the computer will choose, okay, so use bracket. So this bracket that I've chosen here means that I want Python to evaluate 2 times a, then after that divide the numerator by that 2 times a. So that's the first root. The first root and the second root, they are similar. The only difference is that in the first one it is plus square root of d, while the second one is what? Minus square root of d. Then we now say return root 1 and what? Root 2. Return r1 and r2. Return r1 and r2. So let's say we now want to evaluate. Let me quickly write. So let's say classwork evaluate or write a Python code to calculate the root of, so let's say x squared minus x minus 6 equals 0. Okay, so we want to evaluate x squared minus x minus 6 equals 0. So what is a here? In this equation, a is 1, so we say a equals 1. B is minus 1, so we say b equals minus 1. And c is what? Minus 6. C equals minus 6. So if you print roots a comma b comma c, you're going to get what? 3 comma minus 2. Okay, 3 comma minus 2. So, and you can check if these roots are correct. So if you put 3 in this equation, 3 squared 9, 9 minus 3 6, 6 minus 6 0. So the answer is correct. The same thing with minus 2. Minus 2 squared 4, 4 minus minus 2, 4 plus 2, which is 6, 6 minus 6 0. So you can see that the roots, the answers gotten are what? They are both correct. So that is how you handle functions in Python. Okay. Okay, so another way that you can handle function in Python, which is less sophisticated compared to def. So as beginners, if you want to create function in Python, just use def. Okay, use this def function, then the name of the function, the parameters, colon, then return the output. But an alternative way of creating function in Python is the lambda function. The lambda function. For example, this function square, we can create it using a lambda function. Let's say lambda function for square equals lambda. So we'll start from lambda, then the name of the function. So we call it what? We call it squared. Okay, we call it the name of the function L squared instead of square. We called it square here. Okay, so here we want to call it L square. That is the square function created from lambda. Then lambda, then the parameters that it depends on, let's say x, then colon, then this output x squared. Okay, so if you call this L square now, so if you say print L square of, let's say 20, so 400. Okay, so that's how you create a lambda function. But this lambda function is just a one-line function. Okay, if you need a one-line function, so that's when you use the lambda function. But for beginners, I strongly recommend that you stick with the def function. Is more robust than using the lambda function. Alright, so I think that's about function. So you should take, I've written the code. I wanted you to take this as classwork. So that you should write a function for h of x equals 3 over 2 sine cube x. So the name of the function will be h. The parameter the function will depend on is what? X. Then the function will return 3 over 2 sine cube x. So please make sure you do this before you check the code. Make sure you do it before you check the code. Okay, then this is another classwork. So I said implement the mathematical function g of t equals exponential e raised to power minus t sine pi t. So again here the name of the function can be g. The parameter, the input parameter is t. then it will return exponential minus t sine pi t. Then that you should evaluate g of 0, g of 1 and g of 2. Please take that as a classwork stroke assignment. Alright, so that's about function. Then the second part of today's class is on file inputs and outputs. How do you create a file in Python? So to create a file in Python, you need to first open the name of the file. So you create a document. Okay, so here I'm calling the document phy. So you have to, if you want to create your file, make sure you know the directory you are working, because after writing the file, okay, after writing on the file will be saved in the directory where you are coding. Okay, so I know where I'm working now. Okay, so you have to know the directory where you are writing your code. So let's just say file 1. Okay, file 1.txt. So we say f. So this is how you start. You can use anything here, but usually I use f. That is, I want to create a file. Open, then the name of the file and the extension. Okay, the name of the file and the what? Extension. The extension here is .txt. The name of the file here is what? File 1. Then w means that you want to write to the file. Then you say f.write. Now you want to write. What do you want to write in the file? You want to write hello world in the file. Then f.close. You must close it. If you do not close it, the file will not be written. Okay, if you delete this and you run, the file will not be created. You must close it. The file will be created, but nothing will be written on the file. So you must close it before something can be written on the file. So let me run. So now I now go to my working directory. Where is my working directory? So this is my working directory. File 1.txt. It has been created, and you can see it is written what? Hello world. So hello world has been written to the file. So that's how you create a file in Python. Okay, now what if you want to put in numbers? You want to you got some results from your research, and you want to print those results to a file. So let's say we want to print all the power, the second order power, the third order and the fourth order power of the numbers between 1 and 20 to a file. It can be 1 and 100. Okay, let's say 1 and 100. So 101. So this print I will print. We have covered how to use the for loop earlier. So this I will start from 1. So it means it will print 1, then 1 square, which is still 1 cube, 1 raised to power 4, which is 1. Then to go to 2, it will print 2, it will print 2 square, which is 4. It will print 2 cube, which is 8. It will print 2 raised to power 4, which is 16. Then to go to 3 until it gets to 100. You know, this range, it will stop at what? 100. Okay, you know Python stops at n minus 1. So if it is 101, it will stop at 101 minus 1, which is 100. So if I write this to a file, I call it powers.dat. That is .dat. If you like, you can use .txt. It doesn't matter. Okay, you can use any extension, but I'm using DAT for data. Usually in physics research, when you see .dat, we know that it is data. Okay, then separation. How do you want to separate the numbers in each column? This will be first column, this will be the second column, then this will be the third column, then this will be the fourth column. So how do you want to separate them? Here I want to separate them using a space. Then file equals f, that is, write this to a file called f, which I already opened there. Then f dot close. So if I run this now, I'm going to get the result. I'm going to get a file powers.dat. Okay, so if I go, this is powers.dat, and that's written all this. So all this up to 100 square, 10,000, 100 cube, 1 million, then 100 raised to power 4. Okay, so it has written from, you can write from we can change it from 100 to 1000. Okay, to 1000. It will write it up to 1000. So it's not a problem for Python. Okay. Now, what if you want to separate the numbers or the columns by a comma? By a comma. So you want to create a comma separated file. So CSV, because CSV is often used in I think the last 5 years or 10 years, CSV is often used in data science and numerical science and such. So it means you are separating the columns by a comma. Okay, so we can create f equals open powers to dot CSV. Then under this separation, instead of using space like here in the first case, we use space to separate the columns. Here we now use what? Comma. Okay, we use comma. So you can open this. Let's run it and create the CSV. You can open the CSV file using what? Microsoft Excel. Okay, using Microsoft Excel. So it will be created as a spreadsheet table. As a table. Okay, as a table. I think this is up to 1000. And you can create up to 10,000 as well. Okay, so that is how you write to a file in Python. Okay, now what if you have written to a file, or you are given a file and you want to import the file to Python? You want to import the data to Python. Let's say we want to import powers.dat. Okay, now there's a function in NumPy. We import it. We say from NumPy import load.txt. Okay, then you now look at the file powers.dat. So let's go to the powers.dat. How many columns? 1 2 3 4 columns. We want to import all of them. So let's call the first one x, the second one y2, the third one y3, the fourth column y4. Or we can say x1, x2, x3, x4. Okay, then we say the load.txt, the name of the file plus the extension. Then unpack equals true. Unpack equals true means that it should separate all the columns, because there are 4 columns. So we have used 4 variables here to denote each column. So if we print x1 here, it will print the first column, that is 1 to 1000. 1 to 1000. It will print that. I think let me reduce it to, we already created the file. Then if I print x2, it will output, that is the square of 1 to 1000. The square of 1 is 1, the square of 2 is 4, the square of 3 is 9, up to the square of 1000, which is 1 million. Okay, and we can also access the x3. And we can do x2 plus x3. Okay, we can do x2 plus what? X3. So it will add the second column and the what? And the third column. We can multiply them, x2 multiplied by x3. We can say x2. So we can do arithmetic operation on them. Why is it easy to do arithmetic operation on them? It's easy because we are using NumPy. You know, I told you when we started with mathematical functions in Python, you know, sine, cos, square root, and so on. We use math. Say from math import sine, from math math import cos, and so on. But I told you that in research, in scientific research, we do not often use math. We use what? NumPy. Okay, so if you use NumPy, you'll be able to access, carry out arithmetic operations on arrays of numbers, not just columns or vectors, arrays. So NumPy is what you use when you are doing scientific research. So this is how you import your data in Python and how you write your data to a file. Okay, so I'm going to stop the video here. Okay, all right, see you later.